Good day, everyone. Welcome to Jamovi for Educational Research Tutorial Series, Episode 15, Correlational Analysis. What is correlation? Correlation is a statistical measure that expresses the extent to which two variables are linearly related, meaning they change together at a constant rate. Is a common tool for describing simple relationships without making a statement about cause and effect. It gives no information on the direction, specifically which variable causes the other to change. Often a significant correlation means absolutely nothing and is purely by chance, especially if you correlate thousands of variables. The claim correlation is not causation means that just because two things correlate does not necessarily mean that one causes the other. Correlations between two things can be caused by a third factor that affects both of them. This sneaky hidden third wheel is called a confounder. To measure the correlation between two variables, Pearson's correlation coefficient is used. It is known as the best method of measuring the association between variables of interest because it is based on the method of covariance. It ranges from -1 to +1. The closer r is to +1 or -1, the more closely the two variables are related. If r is close to 0, there is no relationship. If r is positive, then as one variable increases, the other also increases. And if it's negative, then as one increases, the other decreases, sometimes referred to as an inverse correlation. The main assumption in this analysis is that the data have a normal distribution and are linear. This analysis will not work well with curvilinear relationships. The assumptions of the Pearson product moment correlation can be easily overlooked. The assumptions are as follows: level of measurement, related pairs, absence of outliers, and linearity. Level of measurement refers to each variable. For a Pearson correlation, each variable should be continuous. If one or both of the variables are ordinal in measurement, then a Spearman correlation could be conducted instead. Here is our sample situation. Teacher Christy wants to determine if there is a significant relationship between reading comprehension and self-regulation. She administered the test measuring students' reading comprehension and the scale measuring self-regulation. And here are the tasks that we will go through in this tutorial. Perform the test, interpret the results, report the analysis. And once your dataset has been successfully imported in the Jamovi software, you are now ready to perform the test. So make sure to keep your focus on the process that has now begun. When it comes to interpretation of results, these are the parts that you have to pay attention to. To be able to know if there is a significant correlation, the p-value must be less than 0.05. And to interpret the results of Pearson's R, look at this table. If we got 0.90 to 1 or -0.90 to -1, the interpretation is very high positive or negative correlation. If we got 0.70 to 0.90 or -0.70 to -0.90, the interpretation is high positive or negative correlation. If we got 0.50 to 0.70 or -0.50 to -0.70, it is moderate positive or negative correlation. If we got 0.30 to 0.50 or -0.30 to -0.50, it is low positive or negative correlation. And if it's 0.0 to 0.30 to 0.0 to -0.30, it is negligible correlate. And as for a result, it falls into moderate positive correlation. This analysis report follows the APA format. Take note of the terms in blue font and the format of reporting values in red font. The study aims to determine if reading comprehension and self-regulation are significantly related. The result of Pearson correlation indicates that there is a significant positive correlation between reading comprehension and self-regulation represented by the given values. The finding suggests that the higher the reading comprehension, the more self-regulated the students are. However, the relationship between the two is moderate. And that ends this session. Thank you for watching Jamovi for Educational Research tutorial series. Stay tuned for the next episode. See you next time.